Hello, welcome back. We're going to do part 2 of section 2.1, and we're going to talk about a continuous relationship, continuous relations. And we're going to ask ourselves, I wonder, what does a continuous relationship look like? How do I determine if a continuous relation is a function? And once I know that it's function, how do I use function notation to evaluate? All right, so that's what we're going to ponder today. Ready? Let's do this. Okay. Some more vocabulary, super important, and it's particularly in the front end of this section, this chapter. All right, a continuous relation. A continuous relation has a smooth line or curve as its graph. Okay, so think of it this way. You can trace it without lifting up your pencil or your finger. Okay, when it's a function, when it's a continuous function, again, every x coordinate is different. Or you can say it must pass that vertical line test that we talked about yesterday. Now, it's different from a discrete function in the way it's classified because it will either always be both onto and one-to-one, so it's both onto and one-to-one, or it is neither, And here's how you tell. If you have an odd degree polynomial, odd degrees, so that would be like an x to the first, or an x cubed, or an x to the fifth, all right? Like x to the first, or x cubed, x fifth, all right? Those are odd degree polynomials. If those are your highest, your ends go in opposite directions. So that means that your domain and your range are all real numbers. Every x produces a different y, and every y is included. So that makes it both, all right? Now, if you have an even degree polynomial like x squared, or x to the fourth, or x to the sixth, all right, your ends are going to go in the same direction. Okay? That's what evens look like. If they are even, then they are not one-to-one. Because negative x's can produce the same y values as a positive x. So they're not one-to-one, and they're not onto, because the range is restricted. There's going to be a minimum value or a maximum value. It's not going to go off in both directions. Okay? So you might want to listen to that slide over again just so that you can try and get a feel for what's going on here. All right, so here we are, and we have some graphs here. I'm going to tell you this is an even function. This is an even function, and this is an odd. I know it by the ends. Here, the ends are going in the same direction. They're both going up, all right? An odd, see how the right one is going up and the left one is going down? It could be flipped, but the ends are going in opposite directions. Ends opposite, ends the same. Okay? And then this one is neither. This is a circle, so this has to be like an x squared plus y squared situation. All right? All right, so now let's start looking at the domain. Domain is kind of tricky, so let's kind of think through what we're doing here. Notice what's happening with this end and this end. Now you have to understand what's happening here. As this goes up, it is also going to the right. And it's hard to see the right movement, okay? As this end is going up, it's also going to the left, okay? So your domain comes from your your right and your left movement. If we say it just keeps going further and further to the left, well, that's negative infinity. And if it keeps going further and further to the right, then that's positive infinity. Our range is a little bit trickier. Notice that we have the smallest point right there. That's it. X equals -2 and y equals -2. My smallest y value, and it includes it, is -2. My biggest y value, it just keeps going up and up and up and up and up. Y's just keep getting bigger and bigger. So that's positive infinity. Okay, is this a function? Yes, because it passes the vertical line test. And it's even, so that means it's a neither. If it's even, it's neither. If it's even, it's neither 1 to 1 or on 2. All right, now on this one, let's talk about our domain. This one keeps going and going and going to the right. I know it's hard to see that, but what it's saying is as it goes up, it keeps going to the right. As it keeps going down, it keeps going to the left. So our domain, just like on this one over here, is negative infinity to positive infinity. Okay. Now look at what's happening with our range. This one just keeps going down, and this one just keeps going up. So if something keeps going down, forever and ever down, that's negative infinity. Forever and ever up, that's positive infinity. Is this a function? Yes, because it passes the vertical line test. And this is an odd function, so this is both. Okay. This one, if we drop a vertical line, it crosses the graph in two parts. So this is not a function because it does not pass the vertical line test. The domain goes from like x is -1 to x is 4. So we would have from -1 to 4. And our y's are going to go from -2 to 1, 2, 3.5. -2 to 3.5. Okay. And we wouldn't classify it because it's not a function. Now, a lot of what you're going to be doing in the homework is you're going to be plotting points, graphing it, stating the domain, the range, whether it's a function, and then classifying it. All right. So this is an odd function because this is raised to the first power. So we're going to plug in some points. So 2 times -2 is -4 plus 2, that's -2. 2 times -1 is -2 plus 2 is 0. 2 times 0 is 0 plus 2 is 2. 2 times 1 is 2 plus 2 is 4. And 2 times 2 is 4 plus 2 is 6. And we're going to graph those points. I'm going to have to use an x here. So I have -2, -2, and I have -1, 0, and I have 0, 2, and I have 1, 4, and I have 2, 6. And I connect it with a line. Okay, so look at what direction my ends are going. This is going, keeps going to the left or to the right, and it keeps going to the left. So what do we say? This is like an odd function. So that means our domain is negative infinity to positive infinity. It's going to the right forever and to the left forever. Okay, it's also keeps going up forever, doesn't it? Just keeps going up and then it keeps going down. So if it keeps going down forever, we say that that also is negative infinity. And if it's going up forever, we say that that's positive infinity. Yes, this is a function because it passes the vertical line test. And because my exponent is odd, this is odd, then we are both 1 to 1 on 2, and 1, 2, 1. This is an even function because my highest exponent is a 2. It's even. So if I plug in a negative 2, I'm going to get negative 2 squared is 4. 4 plus 1 is 5. Negative 1 squared is positive 1. 1 plus 1 is 2. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. And we're going to graph those points. Negative 2, 5, right here. Negative 1, positive 2, 0, 1, 1, 2, and 2, 5. So you see how we have y's that are repeating? So that means it's not 1 to 1, okay? And do you see how we have a minimum value of y? We have a minimum value of y, so that means that it's not on 2, okay? We don't use any of these y's down in this direction. So my domain is, it's going negative infinity to positive infinity, but my range, this value right here, my y value, my smallest y value is a 1. And then it just keeps going on forever in the positive direction in both sections, both sides. Okay? It is a function because it passes the vertical line test, but it's even, so that means it is neither 1 to 1 or on 2. Now we're going to talk about function notation, and this is just another way of writing our dependent variable y. It is f of x. Say it a couple times. F of x. It's not f times x. It's not x times f. It's f of x. You're looking for the y value when x is a certain number, okay? In equation form, what we're used to seeing, y equals x plus 2. The same expression written in a different notation is f of x is equal to x plus 2. What's changed? Just this. You take out the y and you put in f of x. Now in equation form, we're asked to, so find the value of y when x is equal to negative 1. So we plug in a negative 1 and we do our order of operations and we get y is equal to 1. All right, in the same notation, when we evaluate in function notation, we're finding f of negative 1. Look at where we put that. F of negative 1. F of negative 1. This means that wherever there is an x on the right-hand side, you plug in whatever's in the parenthesis there, okay? F of negative 1. I take out the x, I put in a negative 1. Then I add 2 to it, and I get 1. You see how I get the same answer? All right? It's the same answer. It's just a different representation. This is function notation. F of negative 1 equals positive 1. That's going to give me the ordered pair negative 1, that's my x, and my y value, or my f of x, is 1. Remember, this is not f times x. It is f of x, or f of the number, f of negative 1. So let's try and find these. I'm going to do 2, 4, and 6, and then I'm going to have you hit pause and do 1, 3, and 5. Okay? So I'm going to find g of 0. So I'm going to use g of x. I'm not going to use f of x. I'm going to use g of x. And wherever there is an x on the right-hand side, I'm going to plug in a 0. So that's 3 times 0 plus 2. So that is 0 plus 2, and you get 2. G of 2/3. Again, I'm going to plug it into g of x, 3x plus 2. Everywhere there's an x on the right, I'm going to plug in 2/3. So I have 3 times 2/3 plus 2. 3 times 2/3 is 2, and 2 plus 2 is equal to 4. Now, I can even plug in other letters. In a little while, we're going to learn that this is a composite function, but we're going to start practicing it now. So I'm going to plug in 1/3 t minus 3. Everywhere there's an x in 3x plus 2. Okay, so I'm going to get 3 times 1/3 t minus 3, and then plus 2. I'm going to scoot that over. I'm just going to work this way. Then I'm going to distribute. So 3 times 1/3 is t. 3 times negative 3 is negative 9 plus 2. So I get t minus 7. G of 1/3 t minus 3 is equal to t minus 7. So go ahead and hit pause, do 1, 3, and 5, and then come back and see how well you did. All right, f of negative 3 is 2 times negative 3 squared minus 2. So I get 2 times 9 minus 2. I multiply before I subtract, so that is 16. F of 1/2 is 2 times 1/2 squared minus 2. So I get 2 times 1/4 is 1/2 minus 2. That's going to be negative 3/2. And f of h, 2 times, instead of having an x, I'm going to plug in an h squared minus 2. So I get 2h squared minus 2, just like that. Okay? All right, these are the problems we're going to do in class tomorrow. If you want to get started, that's fine. Maybe do a couple of them just to reinforce what you learned. If there was something that you didn't understand, rewatch. Thanks so much, and I'll see you tomorrow.